Welcome back to the Cave of Science, and today we're going to look at some simple models of the VSEPR theory, or the valence shell electron pair repulsion. And these are models predict 3D molecular geometry. We're going to use the AX method, where A is the central atom, X is the covalent bonds, and then E is the number of unshared pairs of electrons. Excuse me. Sometimes these two are referred to as the steric number. So we're going to do a few examples here of some simple molecular geometry. And the first one we're going to look at is CO2. So that's carbon dioxide. And if we were to draw the model with the shared pairs of electrons, we would probably draw it something like this. And it would be a linear model here. Well, when you do the VSEPR, you really don't need to show the bonds here if there's double or triple. All you can do is indicate the molecular geometry with a single line on here. So essentially what we would show here using our model would just be single, or a line to represent the covalently bonded electrons. And if we were to go ahead and write this in the AXE method, so A would be the central atom. So X is the number of covalent bonds, would be X with a subscript of 2. And this would be a linear model here. So this would be linear. So it takes the general form of AX2. Let's go ahead and do a couple more here. See if I can get this down a little bit. So let's look at boron trifluoride, or BF3. All right, so if we were to go ahead and draw this out, we would draw it with the boron being our central, and then we would have fluorine coming off on the sides here. If this is, if we're looking at the AX model, this would be A, our central atom, which is typically going to be the first one. And then we have 3 shared pairs or covalent bonds here. And again, we're not worried if there's single, double, or triple. There's going to be 3 of them. And so this would be an AX3 model. And this is called trigonal planar. So this is trigonal planar. Trigonal planar. And the bond angle on this between these here is going to be 120 degrees. So when you get to a AX3, that is trigonal planar, excuse me. Let's go ahead and do another one. And again, we're just doing simple ones. We're not going to get into some real detailed ones. These are the ones you would most likely see in a general chemistry class. So let's look at sulfur dioxide. So what we would have here, if we were to draw this, we got our sulfur. We're going to have an unshared pair up here. And these are actually double bonds, but again, we're doing molecular geometry. We really don't need to show the double bond there. And if we are going to write this as an AXE, so we have our central atom, which would be the sulfur. Our X, or covalent bonds, would be 2. And then our E, we actually have 1 unshared pair of electrons. So we have an 8X subscript 2E. And this is going to be bent or angular. So this is bent, sometimes called angular. And what's nice about the AXE method, this really shows you I have two bonding pairs, and then I have one unshared pair of electrons. And so that would be our AX2E. The angle here is going to be less than 120 degrees. Less than 120. And we've got these two electrons sitting, you want to think of it three-dimensionally on top there. All right, let's go on down to another one. And let's do CH4 or methane. So CH4, we can go ahead. This gets a little harder to draw in three-dimensional, but we'll see what we can do here. So we got H. Again, these are the covalent bonds here. And then we have another one here. And we have another one out here. So these would be our bonds here. These are going to be about 109 degrees apart. This is a tetrahedral. And this one in the AX nomenclature would be AX4. And when you see an AX4, you can think of a tetrahedral type of geometry structure here. So we got our H's here. You can almost think of it somewhat as a pyramid somewhat. Let's go on down and do another one here. Let's do ammonia, NH3. Ammonia, got our central atom, actually has an unshared pair. Whoops. See if we can get rid of that. We'll scratch that out of there and just put our unshared pair right here. We have a hydrogen coming off. We've got another hydrogen, and again, trying to draw this three-dimensionally. And we have another hydrogen. And our X would be A, 3 covalent bonds and 1 unshared pair. So it's an AX subscript 3E. And this is trigonal pyramid. And a pyramid. So we have 3 bonding pairs of electrons that are bonding, and then 1 unshared pair. So there's our AX subscript 3, and then E. Let's do our last one, and a very common one. And our last one, I should probably put down, this is going to be less than 109 degrees also. So not much difference in the tetrahedral. The same type of bonding angle here. So let's do water, and that's a pretty common one. You see quite a bit. So H2O. And if we were to draw our geometry here, got our shared pairs, and there's actually going to be 2 unshared pairs sitting on top. That's what makes water so polar. We have a negative charge up here and a little more positive down here. The angle down here is going to be about 104.5 degrees. Excuse me. So if we want to name it, it would be A. And then the X, we have two bonds, and then we also have two unshared pairs. And this would also be referred to as angular bent. Which is a very classic geometry of water. So we hope this helps a little bit. And again, there are many, many others, but we're sticking with some simple ones you would see in a general chemistry course. Okay, until next time.